Okay, we're going to go over surface area and volume of composite figures, okay? And we're going to start with the surface area of a figure. We have this lovely building, we'll say it was. And we need to find the surface area of this building, which is actually probably the harder of the two things we need to find. So, we're going to point out the two three-dimensional shapes that are involved in this. What is the three-dimensional shape on the bottom here? It's not a cube. It's a rectangular prism. To be a cube, all the sides have to be the exact same, okay? Everything would have to be the same length, which is not what we have here. In fact, they're all very different. It looks very much like a cube because I didn't draw it to scale very well, but that's the idea. So we have a rectangular prism, okay? And what other three-dimensional shape do we have? We have half of a cylinder. Okay?
What?
Oops, sorry.
It's a cylinder. It's a three-dimensional shape.
Is that how you spell it? No, that's not it. L-Y. Is it L-N-D here?
No, it can't.
There we go. Thank you. Spelling's off. Anyways, and essentially we have half of that cylinder. Okay? So, that means we need two major formulas at least for these two objects. So, for our rectangular prism, we're going to go for the surface area, and I'm going to put a little subscript here, RP, which means for the rectangular prism. The surface area is essentially the area of every face of a three-dimensional object. So, we're going to try to highlight this, and it's going to get a little messy. But this will be our first face here. Okay? The front, and then yellow goes across in the back. The front and the back will both have the same area to them. And the reason being is because they're both using this base and this height. So instead of keeping them separate, we'll put them together. So if we find the area of this first face, we just have to multiply it by 2. So we're going to give them letters. We're going to call this the length, the height, and the depth. Okay, so L, D, and H. I've given them all different letters. So for the yellow faces, that would be L times what? H, that's right. So we have L times H. And how many are there of these? Times 2. Okay. So those are the yellow faces. For the green faces we're about to do, similar idea. Unfortunate. For the green faces, what sides will we be multiplying for those? The D and the H. Okay, so D times H, and how many are there? Excellent. And finally, the last ones, we'll do it the darkest color here, are going to be the top and the bottom. Okay? What sides will we be multiplying to find the areas of all of those? What is it? It's going to be depth and length. Okay? So very important to realize. And how many are there? 2. So once we have these, what do we do with the areas of all of them? Do we multiply, divide? No. Add. I add the areas of all of them together to get the total surface area of this. So you guys probably have a formula, something similar to this in your agenda. But this is the idea of how to build it if you're unsure. Okay? So for a surface area of our rectangular prism, now that we have these letters, we can just simply plug values in. The L in this case was 20. And the H, which was height, was 50. The D was 40. The depth, the height is 50 again. And 40 is the depth, and the length is 20. Okay. So we're going to try these. This should be 1,000, 2,000. Somebody follow along with the calculator. Sometimes I make errors here. 2,000, 4,000. And 800, 1,600, I think?
Yeah.
So that means we should have 7,600 meters squared. So that's the surface area of this shape. Now, I want you to keep this in mind. If I'm looking at a building, I don't need to find what? Well, yeah, that's right, because the roof of this is now a cylinder. Okay? So we might actually eliminate this. What else do I don't usually have to find if I'm finding the surface area of a building? The bottom. The bottom I probably don't have to find. Okay? But let's say in this case we do have to find the bottom. The top one is probably going to be irrelevant. Okay? So we do have to take the top one out. What is the area of this top one? How do I find it?
You find 60 by 2.
What would it be by 2?
Subtract 800.
What is the area of this part right here?
800.
That's right, it's 800. Oh, no, sorry, it's not 800. What is it? Oh, you're right. Thank you. It is 800. Thank you. It is 800. It's 20 times 40. Okay? So, in other words, what we could have done in this part is we could have, instead of having 2, we could have only dealt with 1. But I wanted to give you the general formula for a rectangular prism. So we need to subtract our 800 from this, because technically the roof is a different shape. So what is the surface area of the bottom of this building? 9? There you go.
Wait, sir, can you just go one more time?
I'll do that again in the second part, okay? So, since we didn't need this here, and the reason being is because we have a cylinder for the roof, we wouldn't find the surface area of something inside of it. We're only talking about the outside, right? So the outside of this is there, and then the front and back of this cylinder. Front, side, back, left, and let's say it's a floating building. We did need the bottom, okay? But we did not need the part inside. I did it just so we got the idea of a rectangular prism's surface area. Okay, next formula. The second shape we have to find is the half of a cylinder that we have on top. Now the problem is I really don't have a lot of the measurements for this. What would the diameter of this circle be? 20. We know that because the base of the building is 20. So we can use that here. This is 20 meters. Now, I can use that to kind of figure out what I'm going with here. Uh-oh, give me a second. Did I do this correctly? All right. So, luckily I did fluke this when I drew it out, because I chose arbitrary numbers. Here's our 20, which is the diameter. Okay. Here's another way I could have figured out the radius of this circle. Okay. How could I figure out the radius? We know that the entire height of the building is 60. And we know the height of the rectangular prism was 50. If we subtract those values, that gives us our radius. What is 60 subtract 50? 10, right? And that makes sense because if the diameter is 20, half of 20 is... Man, I
Sir, does that work out every time?
if it's a circle, it does. Yeah. So, surface area of a rectangular prism. Of a rectangular prism. Okay, so let's kind of draw our shape here to get an idea. A rectangular prism has a circle on the top and the bottom. The area of one circle is what? Pi r squared. How many circles are there in a cylinder?
2.
There are 2. So we need 2 of those. Now the second part that's really hard about this is the shape in the middle is technically a rectangle wrapped around a circle. Okay? The height of this object here we'll call h. But the distance across here is actually the circumference of the circle. Okay? What is a formula for circumference of a circle?
Pi r squared. Pi r squared.
Pi times the diameter. Okay? And there's only one. So this is actually called pi times the diameter. So to find the area of this, we would multiply h times pi times d. Once we have all the areas, we add them together. Yours may be written a little different, and this is not an exponent. Okay, so again, this is the surface area of that cylinder. So our r in this case, we decided was 10, the radius. So we have 2 pi times 10 squared plus the height. The height is technically a distance across here. I should use a different color. It's getting a little dark. The distance across here is 40. So we're going to replace h with 40. Pi is a number. Times d. The diameter was how far? 20. It's double the radius, right? So here are all of our numbers. This ends up being 100, or 10 squared is 100 times 2 is 200 pi plus 800 pi. Okay? It's 1,000 pi. Don't worry about how I did that. You can multiply it here if you like. That means it would be 3,142. Is that right? I don't know pi off the top of my head. 141.
Okay.
Beautiful.
Thank you, Kira.
Excellent. So that's meters squared. But are we looking for the entire surface area of a cylinder? What do we have to do to this number? Divide that by 2. So what is that divided by 2? Who's got a calculator that can help us out?
Is that 314.1 points?
Oh, wait.
Nobody has a calculator. Okay.
Higher radius. What the hell?
1,507. I didn't hear you.
1,570.795.
Perfect. Now, this is one of the surface areas, the one of the cylinder. Our other surface area was the rectangular prism. To find the total building, we got to add them together. So we need to add 6,800 to this number, which gives us 8,370 meters squared, not cubed, for the surface area.